All right, let's take a look at exercise 9-6, which deals with direct material and direct labor variances. Let me read the information to you. Dawson Toys produces a toy called the Maze. The company has recently established a standard cost system to help control cost, and they've established the following standards. Okay, so it takes 6 microns per toy at 32 cents per micron. That's for materials. For direct labor, it's $1.4 hours per toy at $6.70 per hour. Then during July, they made 4,500 mazes, and production data for the month were 79,000 microns were purchased at 0.3 per micron. 45,250 were still in inventory at the end of the month. And 6,600 direct labor hours were worked at a cost of $47,520. So let's take a look at requirement 1, which is to compute the direct material price and quantity variance for July. All right. First, we're going to use the 3-column approach, and this is the approach I really like to use with variances. There's other ways, and I'll show that in a minute, but what I like to do is always start off with actual on the left. It's actual times actual, standard on the right, standard times standard, and there's this middle zone, which is usually actual quantity times standard price. Okay, once we have that, we can slide down and come up with some information to see if we can calculate the variances. All right, so we've got to do a couple things here. I want to slide the screen a little bit. Okay, now I've repositioned the screen. Well, let's start off with standard first. We can start it either way, but I like to start at standard sometimes. 79,000, the standards are 6 microns at 32 cents each. So what do we know? We know the standard called for 27,000 microns. And how do we know that? They made 4,500 toys times 6 microns per toy. So we're using that information there and that information there. So that gives us 27,000 microns were expected to be made at standard at a cost of 32 cents per micron. That's the 32 cents, and that's how we come up with 8,640. Next, let's jump over to the left. Boy, I can't talk today at all. All right, well, we made 79,000 microns at a cost of 3 cents per micron. So we multiply that and we come up with total actual input at an actual price of $23,700. Now, that was the 79,000 we purchased. We then need to compare that same 79,000 at the standard price of 0.32 cents, right? We got that from here. And we come up with 25,280. So the difference between the 25,280 and the 23,700 is the price variance, and it's favorable. It's favorable because the actual 23,700 is less than the actual and standard price. Easier way to look at that is just look at the difference in price. 0.30 is less than 0.32. All right, so that gives us a price variance of 1,580. But now we need to figure out, well, what did we actually use in production? And what we actually used was 33,750 microns at 32 cents each to come up with 10,800. All right. So where did the 33,750 came from? We purchased 79,000, and there were 45,250 at the end. So that leaves us with 33,750 microns that we must have used, right? So 33,750 microns were entered into production at a 32 cents standard cost is 10,800. And then we compare that to what we expected to use, and that we already calculated. It was 8,640, which was 27,000 microns at 32 cents. Since the 10,800 is greater than the 8,640, the quantity variance then is $2,160. Okay, now if you want to see an alternate way to solve this one, You could do it this way. You can take the 79,000 purchased microns and compare it to the 3 cent that we actually paid per micron to the 32 cents, and that'll give you a favorable variance of 1,580, because what we're taking is the actual quantity times the difference between the actual price and the standard price. For the quantity variance, we would take the standard price, the 32 cents, now we're working this formula here, times the difference between the actual quantity that we used and the standard quantity that we should have used. So we have the 33,750 microns we actually used in production versus the 27,000 we should have. So this is an alternative way, maybe a faster way to solve it, but I do like laying it out in the column approach.